Welcome. In this video, we'll connect what you already understand about arrays and partial products to the standard multiplication algorithm. This connection is critical for helping students understand why the algorithm works, not just how to follow the steps. Let's consider 73 times 85. We'll start by multiplying 73 by 5. The 5 represents 5 ones, so we start by multiplying 5 times 3 to get 15. We write down the 5 ones from the 15 and regroup the 10 ones into one 10. This is often called carrying the 1, but what's really happening is regrouping, just like in addition. We're not carrying a digit, we're regrouping 10 ones into one 10. Next, we have 5 times 7 tens. That gives us 35 tens. Plus the regrouped 10 gives us a total of 36 tens. So we'll write this down as well. Now we move to multiplying 73 by 8. But remember, this 8 represents 8 tens, or 80. This is why we move over one place before writing the next row. That shift represents multiplying by tens instead of ones. 8 times 3 is 24. So we write down our 4 and regroup the two tens. And once again, we shift over by that place because we're actually multiplying by 80, not 8. 8 times 7 is then going to be 56, plus that 2 gives us 58. Regroup as needed, and always think in terms of place value, not digits. Next, we need to add these, which gives us the product of 6,205. When we add the two rows together, we're actually adding the same partial products we saw in the array and the partial products methods, just written more compactly. You're doing great work unpacking this deeply. This understanding makes a huge difference to students. Let's apply everything we've learned to a larger problem, 179 by 64. We start by multiplying the 179 by 4, the ones place. And we need to work carefully. Multiply 4 by each digit, regroup when necessary. And it's helpful to always think about what's being regrouped, ones into tens, tens into hundreds, etc. 9 ones times 4 ones is going to be 36 ones. We write down the 6 and we regroup 3 tens. 4 ones times 7 tens will be 28 tens, plus that extra 3 tens gives us 31 tens. We write down the 110 and we regroup those 30 tens into 3 hundreds. 4 ones times 100 is going to be 4 hundreds, plus the 3 gives us 7 hundreds. So that gives us 716. Next, we multiply 179 by 6. But remember, this 6 represents 6 tens, or 60. So we move over one place before writing this row. It isn't just a rule, it's representing a shift in place value. We're going to multiply step by step, regrouping as needed, and then add the two rows together. 6 times 9 is going to be 54. We write down our 4, and we're going to regroup those 5 tens into that tens place. Next, we have the 6 times 7. That's going to give us 42, plus those extra 5 tens is going to be 47. We write down our 7 tens and we regroup the 4 into 4 hundreds. 6 times 100 will be 6, plus the 4 gives me 10. And then we need to add. When we do, we get 11,456. At every step of this process, remind yourself, this algorithm is a compressed version of partial products, which itself comes directly from arrays and area models. You've just completed a full conceptual journey from visual models to symbolic efficiency, and that's exactly what we want for children too. You're doing amazing work preparing to teach multiplication in a meaningful, confident way. Keep going. You're building real mathematical power.